Ay, cerrecos, no te puedo creer. Miau, miau. Todo el mundo escuchando, miau, 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 miau. No me hagas reír.
Bueno, los vamos invitando.
So please take your seats. Well, we set up the devices. Let me do the introductions. This session is a secure routing lab and route validation. The intention is to practice the things we saw this morning. Let me introduce the facilitators. Silvia Chavez, who is a computer scientist. Silvia is from Mexico. She has worked in academic networks and in IXPs. She is an instructor of LACNIC's campus. Then we have Santiago Agio, who's an electronics engineer who specialized in data networks and computer networks for scientific and academic networks. He works at CONICET from Argentina. And Nicolas Antoniello, who is senior manager for the Latin America Caribbean region. He is technical engagement manager. He works for ICANN. Nico has worked for a long time in network operations. He has a really deep knowledge on the topic. So try to make the most of this session. He will speak on and on if you allow him, but feel free to interrupt him if you have any questions. The intention of the lab is precisely to clarify any questions that you might have and make the most of the experts that are here with us today. So we will continue until 4 p.m. and we'll have a coffee break at 4 p.m. Silvia, the floor is yours. Good afternoon, everyone. It is a pleasure to have people in the second session this afternoon. This morning, with Guillermo and with Erica, we looked into the theoretical aspect of what is done in secure routing, everything involving best practices such as manners, also RPKI, the ROAs. Some prizes were distributed, and during this tutorial, we're also going to have some prizes from Campus LACNIC. So those of you here came to the morning workshop. All right. So now let us look at the practical side to see a laboratory with a simulation of what would be the connection of an IXP to the access to the internet, the filters, and we'll have the Fort validator for this part. So step by step, we'll be following a very practical guideline that will take us by the hand as we go along. So you can all participate in a personalized way. You can take out your laptops and set up a working group. We will now explain how we set up each of these groups. But this is easier. Don't be fearful. We invite you to take out your laptops and start working. so that this is really hands-on. Hi, good afternoon. The first recommendation is to please come closer so we can have you all in front of us, and we will be giving you a group number. So it's better if you come closer to where we are. Like and like Guillermo, who also has a nickname, we call him Chicho. So we all have nicknames. So the rest of you, if you haven't set up your laptops yet, and if you don't wish to feel around, okay. But those who do have some freedom of movement, if you're over there in the far west, please come closer. You can sit in the middle of the room, please. So we're all better over here together. Of course, well, if you're ready, set up your laptop. And if you had a good lunch, you can stay where you are seated otherwise. So a couple of things before we start. First, this is for you. It will be extremely boring if no one participates. There's like some feedback with the microphone. So please take part. Clarify any questions. I got stuck or whatever. Please let me know. So I'm standing rather close to the edge, but well. Anyway, if you have any questions as we go along, if you want to ask anything, if you're unable to do something, please raise your hand, ask for help. There will be people here who can assist you. Erica, Guillermo, we will be here to help you. If you get stuck, if you cannot advance, just raise your hand and let us know and ask for help, because the laboratory is something we'll be doing together. So if you get stuck in the lab and you cannot advance, you won't be able to recover afterwards. So whenever something stops working, when you cannot do something, just feel free to ask. We will advance at a pace that can be adjusted to your requirements. Nico, let me say something. Erica will be there, and also Celsa will be supporting us. Whenever you have any doubts, if you cannot connect or what was the link, and so on. Thank you, Sylvia. So a couple of considerations. This is the part that Guillermo likes doing. He's like the bad policeman. He loves that role. They told me he was like the bad policeman when he was in the previous session. He sent you over to have lunch. He just stopped the session. Okay, just joking. The lab we're going to use, we're working on, is a lab that runs on a cloud computing cloud. It starts with A and ends with N. I'm not going to say which provider this is. This is a virtual laboratory. Each one of you will receive a network infrastructure with several networks, with several devices connected to it. And specifically, you'll have a router that you're going to manage, and you're going to have a customer connected to a network connected to that router that you will also have to manage. So both the router and the customer are running each in a container, in a virtual machine. The client is it's a Ubuntu server. We're going to use that customer to execute queries, and we're going, like we would normally do with a client, we do some traces as well as other types of queries that have to do with routing.
Va a ser lo que principalmente vamos a configurar a partir de ahora en todo el resto de la tarde.
And that's what we will do for the rest of the afternoon. The router is a soft router, the software, but it's fully functional. And it is the same, and in many cases more powerful than many routers, especially more powerful than small routers. It's an FRR. Many of you might be familiar with the soft router. Maybe some of you are familiar with the old name. Before it entered the wetness protection program, the FRR was called Quagga. And it is a router that implements all the router functionalities you can think of, basically. It just has different modules that most of them are enabled for the basic router functions, and then there are others that you need to enable if you want to do some things like BGP, if you want to implement ISIS, OSPF, you have to go to settings and enable those modules, and that's it. You deactivate the processes in the router, and the router already supports the different protocols. For RPKI, it's the same. It's not enabled by default. You have to execute two, if I'm not mistaken, lines in the settings to enable the RPKI protocol to support and connect to an RPKI validator. Why am I saying this? Because the FRR router is a router that you can install at home, at work, for testing, to replicate what we're doing now. In any environment like VirtualBox, which is free distribution, open distribution, so is FRR. You have it in Linux and you install it with a single command. If you use Evian or Ubuntu, you go apt install FRR and that's it. It's running. After installing it, you execute BTI-ECH and you access the command line, the router, and it is very similar to the Cisco CLI. Cisco CLI before XR. XR might work different, but if you're used to configuring non-XR Cisco routers, it's pretty much the same. There are some small differences or enhancements that the FRR team did to the original Cisco. If you execute show XP, it will only show IPv6 as it should. In the past, if it says show IPHP, it would show IPv4, and if you wanted to do IPv6, there was other options to select a very, very long command. You now do just show BGP and it displays the full table. So that infrastructure that you will have, to access it, you will need a notebook or a desktop. But who works on a desktop? Raise your hand. No one, right? Okay, a notebook, browser. Do not use your phone. Do not use a tablet. It won't work well. And if you have a VPN activated, disconnect it also, because it could cause trouble. Now, if you're going to connect to a website through the HTTPS protocol, this is a simulation. At some point, we will have a terminal, a command line terminal, a regular Linux command line terminal simulating DCH over HTTPS. The routers are soft routers, but are actual routers connected to the actual internet, so to speak, and so is the client. So the entire lab network is connected through a BGP session to an actual carrier, and we are receiving the full routes table for the internet. What we do, so we do not inject the full route list, 1.5 million routes to your routers. What we do is we filter and we keep only a few routes, 30 something IPv4 and about 50 IPv6, to run the lab, but these are actual routes. We just use the title because if we inject 1.5 million routes to each router, we are probably going to crash the platform, and we just crash it, and we are using up the full memory of the devices. The platform is now running 100 and something virtual routers on over 100 clients. So over 200 devices executing and running simultaneously on the same virtual machine. So it's a big memory consumption. If on top of that we add 1.5 million, that would be too much. Your connection is through the router as well. This is not a simulation. They are in an actual router. It's a soft router though. So if you for example, download any interface or change any of the settings in the router interface, and that runs a big risk, and you lose access to the lab because you will be using the same router to the lab, and they don't have bandwidth. So if you cut off the branch where you're standing, that tree falls. Well, the tree doesn't fall, you fall, and you are kicked out of the lab, right? So what am I saying is just let's do it together, let's do it gradually, let's take it easy. So raise your hand, all of you who are sort of technical experts. Raise your hand, please. Okay, a lot of you are here. The problem of us technical experts, if we have a button and we know how something is done and we know how to do it, we'll just do it in advance. If it's a red button, we just go ahead and click it. And if we know how to do something, we don't wait for instructions, but rather we get ahead and we do it before. Just don't do it. If you're hungry, just chew on your nails. But please don't jump ahead. I want everyone to do it at the same time together, at least today. After practice, you can go ahead and play with it, but for now, let's just stick together. Okay, so the first thing that we need to do, and we will need the help from our colleagues, is to assign a different group to each one of you. So they will come to your desks, and well, those of you who are participating in the practice will be grouped. Groups 1 to 100. So once you have that number, please write it down. Don't try to memorize it because you'll probably forget it, and then you'll have to go back and ask what your number was. So just please write that number down, and we will use it for the rest of the afternoon. It will be your group identifier. Guichet, do you want to do the honors? He ran away. He knew this part was coming and he ran. So while we assign the numbers starting from 6 to 99, let's say, so you can start with 10 and she can begin with 50, and well, we can group participants. Can you please project what I'm sharing on Zoom? Is it possible? Well, we can see that in a minute. Well, yeah, but so you can have a more visual representation of what Nico already showed. So this is the graph that we will use. So the X is the number that you will be assigned. So that is your group number. So we can start working on the correct settings, and then we will refer to the group number based on the settings, and that is the chart. The client that Nico mentioned, and also your router, the router that you will set up. So that's for a more visual representation of what we've explained. Thank you, Silvia. Okay, I will now. So while you receive your group number, let me share the credentials. Okay, so let's do this. We need to give you the credentials for the lab. So, if you are attending this presentation remotely, the lab is conceived to do it in person. If you are joining remotely, you can follow our session, but you cannot do it at home. Again, if you're joining remotely, you can follow, you can ask questions in the chat or, well, the different channels, but you will not be able to engage in the hands on practice, only for those who are here in person. So, is it possible for me to show something on screen and sort of disconnect the streaming for a few seconds? I don't want the video that I will show here to be shown for those online. I don't know if anyone heard me. For those responsible for stream, Edu, can we just interrupt streaming but keep the screen for a minute? That was not planned. Well, maybe not interrupt streaming, but maybe have something to cover it or
Ya la traigo. Son 2 segundos, digamos, es 5 minutos menos.
it's just for 5 minutes, 2 minutes.
¿Ya asignaron todos los grupos? ¿Sí? ¿Alguien no tiene grupo asignado?
Have you all been assigned to a group? Is there anything who hasn't been assigned to a group? So we're going to show you now is how to access
¿Eh?
¿Cómo crees que esto no se vea en el Zoom?
Sí, que solo se vea en la pantalla.
¿Eh?
Claro, quiero que esto se vea solo en la pantalla, pero no en el
Juan, sí, quiero que esto se vea solo en la pantalla, pero no en el Zoom. Sí, ahí lo lanzan y nosotros mantenemos planos close para que no se vea.
Claro, pero que tampoco se vea la cámara, porque si la cámara apunta a la pantalla, marchamos. Sí.
Bueno, mientras se va resolviendo esa...
In the meantime, while they get settled, once again, I put the image of the maquette so you can start having that as a reference for those who have just arrived. Here, where we have RTRX, where we have the network to the... Is the router going to use? The one that goes to RTRX. Do we have the client in the internal network? I'm going to do a peer BGP to the red line, which is a BGP session that we're having towards our border. That is where we will have the two servers for validating RPKI. That is why we have RPKI 1 and RPKI 2, so that we can get familiarized with this and can set up all the devices with what we saw this morning, namely filtering, validation, connection to the RPKI servers. And remember that this first part prior to the break will be for the manual part, and after the break we will have a second session with Ansible in order to do the automation, so that with Santiago, as Nico is saying, we used to calling ourselves with our nicknames. So together with Santiago, we'll be starting with that part. Would you like to add anything? In the meantime, until you take that into account for the second part.
Me dicen si dejo de compartir yo. Bien. Ahí aparece.
There you have the URL for the lab. Nicolas will be telling you. So what you see over there on the screen are the credentials to access the lab. So those of you who are here, please take a picture of that. So when we remove it, you have it there. Now, basically, to access the lab, you have to access this, right? sv.te-labs.training. You don't need to write HTTPS. Use this username and this password. Respect uppercase and lowercase. This is all lowercase. And this has this letter in uppercase and this letter in uppercase as well. The first letter is uppercase and the third letter is uppercase. If you enter that correctly, they will take you to a screen that has a list of groups, and wait there. If you see a beautiful list, graphically speaking, with a large amount of groups there, then this means that you connected correctly. So let us wait for a couple of seconds, until everyone can get connected.
Y después, si no cierran,
And after that, if you don't shut down the browser, you will not need your username. The browser will remember this, so you'll no longer need that information for the remainder of the practice. Like Silvia was saying, the X stands for the group assigned. You have to replace that for the number. We're not going to use the group number yet. We're going to use this throughout the practice session. Once we copy and paste configurations, we're going to replace whenever the X appears. Each one will be replacing it for your own group number. So raise your hand if you haven't been able to access this site. Raise your hand. Guillermo's the only one who couldn't access? Okay. Right. So let us disconnect this over here.
Está bien, pudo haber sido peor. Ya, ¿lo desconectamos? ¿Lo desconecto yo o conectalo vos? Así si explota todo y no tiene nada que ver.
So disconnected. Okay, thank you. And now we can have everything back to normal.
Bien. Me tengo que tomar un Uber para...
So I'll now go back to the table over there.
Entonces,
Right. Now let us start with a practice session. So can you see it? So if you all entered the username and the password correctly, you should all be at this screen right now. Here we have a couple of things before accessing each of the groups. If you clicked on it and took a step forward, just go back, please. Before accessing the group, at the top, you have two things that you need. The first is the practice guide for the lab. If you click on open, I will click there. Let's click on open. And here you have a display of information on the lab. We're going to use some of these guides today and others not. The others explain. This one over here is in English and has subtitles in Portuguese and Spanish as to how you can configure an RPKI validator using the Fort validating software. There's a video that takes you step by step how to download it, configure it, and start from scratch with a Fort validator in any Linux system. And then a lot of additional information that will be useful. The one that we'll be using today is the one that has practical interconnection and RPKI guide. It's available in English, in Portuguese, and in Spanish. So you can select the one, the language that you speak. I will click on the one in Spanish, the interconnection and RPKI practical guide. But if you wish to open the Portuguese or the English version, the three are similar and have been translated. This has been a courtesy of Nick BR that allowed us to translate all this into Portuguese. So now click on the one in Spanish, but you can select whichever one you wish.
Un segundo. Me parece que... Voy a corroborar una cosa nomás.
Algunas personas llegaron.
Some people have just arrived. Raise your hand so we can help you to get your group assigned so you can also participate in this practice session. Over there, someone, and also there at the back, a couple of guys have just come in. Then there's something else. Let me go back. I'll open the correct one in Spanish and you can open the one you wish. I was just checking that the IP addresses were all correct, just in case. So In the other line at the top where you have router passwords, we're going to use that after the break in the second part of the lab. Whenever you click on these links, this window won't close. It displays another window. So if you need to go back, this will remain open. And so it won't ask you again for your username and your password. So now you can look up your group number and you will then click on the correct link to access your own lab. I am group number 1 because I prepared this lab. This is what anyone would do if you are the one who sets this up. Silvia has group number 2. Santiago has group number 3. So how do you know if you are in the correct group? Well, if you're in group 25, it would see at the top GRP 25, for example. Close that window and try again. Like Silvia explained, this is the network topology that we're going to use. The one in red, that network. This over here is blue, this one here is violet or purple, and at the bottom it's a green one. The network at the top is the one that connects the laboratory to the internet. It's like the backbone of the network. That network has this router over here, which is a border router. This router doesn't take part of the lab ecosystem directly. It's the one that allows us to connect the platform to the internet. On that network, we have the border router, which will be the router of our traffic exchange point. So the first thing that we're going to do now in the practice session, as Silvia will explain, is to connect to this router to establish a session, a BGP session from each of your routers, which are these over here, RTRX. These are the routers that you will be managing. We're going to establish a BGP session between each of our routers and the traffic exchange point router, similar to what you would do when we establish a peer, a relation, or connect to a traffic exchange point. So once we establish the BGP session with a central router for the traffic exchange point, we'll start to receive from the IXP all the routes. The BGP table at the beginning is empty, and once we connect to the traffic exchange point, we start to receive all the routes from the traffic exchange point. This one over here is a router that receives a partial view of the table, we call the global IP table. This router over here, from the standpoint of the traffic exchange point, is connected as a BGP session with a router of a carrier. That router is sending us the full routing table for IPv4 and for IPv6. The entire lab is dual stack. For this reason, the remaining of the laboratory would be done with IPv6 addresses. We're now used to having all the examples with IPv4, but today that is not the case. We're going to do all the examples with IPv6, but the lab supports both IPv4 and IPv6. In addition to that, on the same network, we have 2 RPKI servers connected and are configured and are working. These are RPKI validators that are running the fault validation software and are functioning and are generating the validation table. Santiago will now show us the setup of these 2 RPKI validators, and we'll be sharing some ideas with you and important things to take into account when you configure an RPKI validator. If you wish to configure an RPKI validator from scratch, remember that at the previous site there is a video guide. We prepared that a few years ago together with Alejandro from LACNIC. And the people from NICPR helped us out translating this and subtitling it in Portuguese, and we use that also for a presentation that we made in the streaming program that they have at NICBR, which I think is called Camada 8, Camada 8. So NICBR has an amazing amount of resources, information, and resources on configuration for RPKI. So these here are functioning. We'll see how these are prepared. Once we establish a BGP session with a traffic exchange point and start to receive the BGP routes, we'll connect each of the routers with the RPKI validators and start to manage the validation information. We'll ask some questions. If you answer correctly, you receive a prize. If you don't answer correctly, well, never mind. And following that, once we have the entire infrastructure operational, we are going to do a simulation. We're to simulate an attack, a specific type of attack, and each one of you and your own routers will have to mitigate that attack applying BGP filters based on the validation status of RPKI. Once again, it won't be a simulation. It's going to be a real attack, but we're going to do that. We're going to keep it confined to the lab. Of course, we don't want to produce a disaster in the internet for a lab, LACNIC lab. And then a couple of other things. And then in the second part, Santiago will explain how to do all these things that we did during the first hour in 5 minutes time using automation tools. So how you can automate what we're going to do first manually, he's going to do that very fast. So you can compare 1 hour versus 1 minute. How to set this up, how to reconfigure, how to go back. Santiago will be showing us a lot of tools. Are you all connected? Could you all access to your network topology? Do you have? I have the lab guide over here. Did anyone arrive late? Do you need a group number? Those of you who arrived late? So here we are. This is the guide for the practice session. What we're going to do for the remainder of the afternoon, we're going to look at this practical guide, and to a large extent the configuration is copying this and modifying it. When you see X, you change that for your group and paste this configuration in your router. But just anyone could do that. It's very straightforward. So prior to that, we're going to explain everything as we go along, discuss this. You can ask as many questions as you wish, ask as many comments as you want. Tell us about your experience. We learn, you learn, we all learn all together. So we'll continue with the lab practice. Once we finish with that, the first part of the practice is verifying the validator configuration, the RPKI Fort validator configuration. Santiago will explain this first part. So how you proceed with this part of the practice.
Okay, here it is. Let's start with RPKI. As Nico explained, we'll have two RPKI servers running on Fort, and the settings of these devices. Always remember that on the one hand, Fort works towards the routers. It will provide the prefixes with their masks. At the same time, it needs to connect to the RIRs and obtain the sign ROS for the 5 RIRs. On the one hand, it will use a protocol that we'll see in a minute, and to the other side, it will connect to the RIRs and bring the information to present to the routers. You can follow this on your own computers, and this is a very basic RPKI configuration for a Fort validator, And what we'll have here are some parameters. For example, the directory where we'll have the .tal files. Those files indicate the validators how to start the connection to the RIRs, the repositories, and retrieve the signed ROAs. We'll also find, for example, some server parameters. The port that it is running, in our case, is 323. The backlog is a Linux configuration to accept up to 100 connections, and then we'll see the interval between router and the validator. So the refresh times for the router, not to constantly ask the validator about the prefixes and the ROAs retrieved. We can establish certain times that we need to use. We cannot constantly, the router cannot constantly ask the validator, and we'll ask it to refresh every so often, and if the information is not found, to dismiss it. Those parameters are similar to what we use in a primary and secondary DNS. When we obtain a zone, that zone has refresh times, expiry times, and so on. Here our validator will use the rsync protocol to connect to the RIR's repositories, the 5 RIRs, and there are other parameters. This is quite a basic configuration, but everything that we obtain, all the prefixes that we obtain, we can indicate that we'll go to a file that is called fort_roas.csv. Here we have a list of the 5.tal for the 5 RIRs, and the Fort validator makes it possible to update them and so to query and to refresh the .tal files. And then you can see the output as to, well, how the validator starts validating. In this case, we can run, well, to execute the tals. Can you see it well, or is the font too small? Well, okay. So here we can obtain the tals, the .tals. These indicate the site and the repository site where I'll retrieve the information and a password. Let me show you. Let me see if you can. This is the TAL file available, publicly available on LACNIC. There are 2 links, one if we use HTTPS and the other one if we use rsync. And below you'll see LACNIC's public key, with which we'll confirm that the data retrieving in the connection, or that the connection is valid. Then it just operates as a regular Linux server, a system control for those that are used to working with it. It is executed and the service is run. And what we'll find when validation starts until it retrieves the 5 ROAs for the 5 RIRs, there is a wait time. That wait time indicates, well, right here we can see that the first validation cycle started, and we need to wait a little bit until it's completed. Why am I saying this? Because when you install a validator, you're going to want to have the ROAs immediately, and that takes some time, a few minutes, until it completes retrieving all of the ROAs for the 5 RIRs. Let's start with the first practice. We're going to simulate a router. So you will go in the network diagram that you have. Remember that Silvia and Nico, yes, this one right here. You have to select where it says select, and then you will trigger a Linux console. Excel. Where it says, I'm sorry, where it says CLI right here. Just click on the icon and a new browser window will pop up with a terminal, with a command line. If it doesn't, something else pops up, close and start it again. Because what could happen when we do it all at the same time, the system is not all able to serve us all at the same time, and it might take some time. But yes, click there and you can access the terminal. So we need to install a package to be able to use what we call RTR client. It is a program that simulates a router query. So we'll execute that command, sudo apt install librtr 0. Yes, we need to wait because all the groups are installing the same package at the same time. So it might take a bit. When you are done, when it's installed, please raise your hand so we can proceed. Remember that the command is sudo space apt space install space librtr 0. Okay, let's proceed. If there's anybody who was not able to install, please raise your hand and we'll help you. Right over there. Anybody else was unable to install the lib0 package? Okay, right over there. Tito, Guillermo, Erika, can you please raise your hand? Can you help him? You're somewhere else. You're distracted. Guillermo and Erika are very distracted. Anybody else? Is there anybody else who needs help? So we have one more person. Okay, so what we will do is we'll continue with the guide. And we'll run the command that you have here. Please copy paste the command in your CLI, RTR client, and well, so on. You can see the parameters on screen. So we run the command and you'll see that it'll run a debugging for different parameters. And what we can see here, it connected through TCP to the first validator, port 323. It does the connection handshake, and will receive PDUs. So that is, each PDU contains a prefix, whether IPv4 or 6. And what we can see below are the parameters that the validator offers. Remember that in the settings, we had the expiry, the refresh interval, 900 seconds. The expiry is 2 hours, 7200 seconds, and so 600 seconds every 10 minutes it will reconnect if it was unable to. And below we'll see syncing, and if you're simulating a router and you received 775,000 prefixes. So when executing the command, we said that the output is a ROAS.csv file. So what you will find in your console we should be able to see that file. And now, if we go back to the guide, you'll find your autonomous system and your prefixes if they are assigned. That is, if you've created the ROAS. So you can look for your IPv4 block or IPv6 or your autonomous system number. I will show you mine, the one I have in Bahía Blanca. So basically the ROAS contains the prefix, the mask length, I will look for my autonomous system. So I look for my autonomous system, 28109, and I'll see the prefixes that I've already validated. The IPv4 and IPv6 blocks. You can look for your prefixes and check whether they've been signed. If they appear here, they've been signed. The ROAS in LACNIC. And the ones that you have in other RIRs. Is there anybody here who is an ISP that can tell us your AS number and we can look it up?
SP acá.
Is anyone from an ISP? A show of hands. What is your number? Go up to the microphone. If the microphone is off, you use a switch at the top of mic. Can we have the audio in the microphone, please? Give us your autonomous system number. 262206. 262206. There we are. So it's looking this up in the file that you downloaded. Like Santiago was saying, there you have all the prefixes for which you, as holders of the autonomous system number 262206, have created. So these are all the rows that you created for each of these prefixes. And the same happens, you know, repeat the same for your autonomous system or for each autonomous system.
Bueno, te paso la palabra, Nico, para continuar.
So, Nico, back to you so you can continue with the lab. You stop sharing then? So there we are. So to continue. So recapping, what did we do so far? Santiago showed us how the RPKI validator is set up with the fault validating software. We did a query using, remind me of the name, please, Santiago, with the RTR client. We did a query to the RPKI validator, and we downloaded all the validation table generated by the validator, which contains all the ROAs, the valid ROAs for the 5 regional registries. So these are all the ROAs you have in the internet. So now we'll continue with a practice session. So we're now going to access the router. We'll start to set up things in the router. Before we start to set things up, first of all, we're going to configure the BGP session with the router for the traffic exchange point. Silvia will explain this, and I will be explaining the basic configuration of each of the routers. To access the router, go to the diagram of the network, click on the router, the one, the RTRX, the one over here. Click on that one, and you will have a window displayed containing the router. So you see, should something like looks like this. Can you view that on your screens? I will enlarge the font size. So did you all manage to enter your routers? Anyone needs any help? Has anyone been able to access the routers? No? Okay, great. So now we will visualize the setup of the router. With that aim, we use the command show. You can just abbreviate it as sh space run. So show run, but sh space run. And we scroll down, and we can speak about the basic configuration. So your router will have configured default routes, a couple of routes. Don't change anything in that configuration because you won't have any lab otherwise. And these default routes have been configured, which are the ones I use to once again connect to the internet. Then you have the 4 interfaces, the one we saw in the diagram. If you go to the configuration diagram, it has all the 4 interfaces. In other words, the one that connects it to this network, which would be the lab backbone. The interface with the LAN network is with the client, and these other 2, which we won't be using in this lab. These are HD0, HD1, HD13. And then you don't have anything else configured, all that only. So now, first of all, we have to add the BGP configuration and establish the BGP session, 2 BGP sessions, one in IPv4 and one in IPv6, against the central router of the traffic exchange point, that is the one we manage. Once you have established all the BGP sessions, we'll continue with the RPKI part. So now I give the floor to Silvia so she can explain step by step what we will be doing and how to set up the BGP session. Prior to that, a couple of things in the router. And just to visualize a couple of things, please execute the command show BGP and click enter. So execute the command show sh space BGP enter. Execute that command. So what do you see? What do you see on the screen? Nothing. What does it say exactly? Not found? Yes, exactly. sh space BGP, and what do you read? Does everyone have not found when you do that? It doesn't find the BGP instance, but you haven't configured anything yet. So this is a command that we normally execute to see the status of the BGP table. But because we don't have a configured BGP session in the router, it will tell us that it doesn't find the BGP process. So now we're going to create the BGP session process, and Silvia will now explain this. Thank you, Nico. So now I will share my screen. Alt button, copy, and then paste. Remember that to paste that configuration in your router, you have to access configuration mode on the router. Maybe you have to explain that part. So first of all, you don't need to enter the BGP for the filters. We can configure these in global configuration. So we access with configure your terminal. And what Nico mentioned, I'm trying to enlarge the font. In the meantime, the command for putting this in configuration mode is conf space T. So you can see the prompt changes and you have the word conf in brackets. So that is in configuration mode. Once you're in configuration mode, you can paste the entire access list that you had in the saved and copy process. So we configure the filters already configured. We are using an FRR, which is very similar to Cisco. We have the configuration so that we can apply certain sentences. Now we have this configuration, so we exit and now once again enter to create the BGP session. So I go back. If you allow me to ask a question. I have a paper and pen. So first question with a prize. It's very easy. Don't think it's going to be so mad. We have very modest prizes, but this is a pen and a pad of the LACNIC campus. The question is, why? And raise your show of hands, please. I'm going to select one of the persons who raises a hand. Why is it necessary to set up the filters before the BGP session? Why don't we configure the BGP session and then afterwards the filters? Why? Some of you will raise your hand, and I won't choose you because you have a lot of experience. Many of you I've known for quite some time. So who can answer? There are no... don't worry if you don't answer the correct thing. And nobody wants to answer in case they're wrong. You shouldn't be afraid. You really should take that step. Over there, yes? Let's see. I'm going to repeat what you said. You might receive the full table. If I don't have the filters, when I start with a BG session, you can get the full table. Anything can happen. So here you are. You won this. He won this notepad and pen. A big round of applause. This should be just because you were brave enough to answer. Why do I have to configure the filters first? If I pick up the BGP session, I have no types of filter, and I would then allow everything to be included in the BGP router, or it might all go to my peers. So that could be quite a disaster, quite a major disaster. So as usual, you have to control the BGP sessions. You do. First, you have to configure the filters, and when I pick up the BGP session, this is picked up with all the filters in place, and not the other way around. Many of us have done that already. We have all done some major mistakes sometime in our life, but this is not a good practice. At least you can do that once, learn from your mistake, and never repeat it. So first of all, we apply the filters, and then you pick up the BGP session. These routers are protected. But in the past, the routers, the same happened with Cisco and all the other routers. You pick up the BGP session without any filters, and the BGP session allowed everything and torture everything. There was route hijack and many /24s and smaller things around in the internet. So it was quite a disaster. So if I don't set up a roadmap for the FRR, the BGP session won't pick up. So when I pick up the BGP session, I haven't configured a roadmap, then this is not this won't work. This is to make sure that even if you might make a mistake or if you just weren't paying attention or lack of knowledge, the router protects itself and doesn't pick up the BGP session. So first the roadmaps and then the BGP session.
It is also important to mention that action number 2 for filtering. So these are good practices to have our filters, as Nico said, to have our filtering, also our inbound networks, the default route, unless it is very necessary. So these are good practices that, well, this is not a full filtering example, especially for you as ISP, as operators, to be careful in this sense. If we follow our configuration guide, we will then need to create the BCP session. X is our group number. Why double X? Because we have 02, 03, or up to 10. But please take that into account when creating your BGP session. At the same time, we have the router ID configuration. There's also an X, and that is our group number as well. We'll then look at the different families, IPv4 and IPv6, to configure our BGP session with the router. Where are we going to apply the filters that we created with the roadmap for all IPv4, inbound, outbound, and the same with IPv6? We have 2 roadmaps, inbound IPv6 and outbound IPv6. Okay, let's go to our router so we can start with the settings. So this is the first very common example that we all make in our lab. The BGP session has 2 parts. I have to configure it and my peer has to do the same. I have to set who my peer is and the peer has to do the same with me. This is a relationship between 2 routers. Now all the BGP sessions are configured. Now it's not being picked up because we're waiting for you to configure it on your end, and then the session should be picked up. Now the problem is that you need to be careful when you configure this first command that Silvia indicated, the BGP router and the autonomous system. Autonomous system is 65,000 ending in your group number. So I am group 1. So my autonomous system is 65,001. So it's 65001. It's not 6501. That would be 6,501. It might sound silly, but trust me, it always happens in the labs. So if you are autonomous system 25, you are going to set up 65025, 65,000 something, ending in the group number that you've been assigned. So please keep that in mind. So we are inside our router, configuration, global, and this is the line that we've copied. 650XX, mine is group number 2, so I'll have 65002. I'm inside. And we will now configure the router ID. Copy paste. Two, because it's group number 2. We configure it, and we now are able to configure the rest. So we are creating our BGP session, IPv4 and IPv6. Okay, let's copy everything. I need to access each and every one of the families. Now to configure within the IPv4 category, address family IPv4 and unicast. So let's do it step by step. Now we will set up our session, our BGP on IPv4, and I will do it here directly for address family IPv6. So we're all set. Let's wait a minute. Are we all okay? Are you all following how to set up our peers, BGP, IPv4, and 6? Is there anyone who was not able to go ahead with the settings? Everyone's been able to do it. Yes? Okay, great. So let's now review what we have within the BGP session with show BGP summary. We have an IPv4, and right here it says that I have already my BGP session up and running towards 65,000, which is the router. Show BGP summary will allow me to see both IPv4 and 6. So right here we have the first part, 65,000 with one neighbor, and IPv6 as well. So what we can see in this board, this command, we have the autonomous system, our neighbor address towards which autonomous system is doing it, and the time. It's important to review the lockdown and the status. With the IPv4 session, as we can see on screen, we have a total of 33 prefixes right here at the end. There are 33 prefixes, and right here with IPv6 there are 58. So it's important that we see all of this to follow what we'll do next to avoid mistakes. So we have the settings. We have reviewed this part. Show BGP summary allows us to see both. After that, we will add the settings for the RPKI validator. Remember when we were looking at the diagram, we could see two RPKI validators. Here we have number 1 and RPKI 2. And I will hand the floor over to Nico so you can review this part and go ahead with the settings. So far we have I will execute the command. I've been doing the same thing you are doing and it's not working for me. Good. Okay, so let me share my screen. Show BGP summary. Just one moment, please. Can you see it well? Yes, from the back? Okay. Let me run the command again. Show BGP summary. So as Silvia said, when we do show BGP summary, we have number of prefixes, 34 in IPv4, 59 IPv6. So show BGP, only show BGP is the new command to see the full route chart, the full BGP chart for V6. Let me go to the beginning where I executed the show BGP command. I'm not really that tall, but up there you can see the show BGP command, then the reference as to what the different data is, and right here next to this reference where it says network, I can see all the routes, each of them where this sign is a route installed in the BGP chart. It is a path to reach a destination. So how do we read a BGP route table? This is a very basic BGP 101 test question. What we can see right here is that this sign, this symbol, the star means that the route is valid, that the route that is a route that we're using to access that network. I could have several routes to reach the same destination. If that were the case, well, the protocol will try to use the best one according to the metrics in the settings and the different criteria to choose the BGP routes. There's a very long list of criteria, and it goes one by one. And the first to meet the criteria is the one that will be picked up as the best route, and that will be the valid one, the one considered valid, and the one that will be used. So what we see is the network, that is the target destination, so 2001 7FBEE00/48. So to reach that network, the next hub is FE80 and so on, the IPv6 address. FE is for auto settings or self settings. I can never remember which one it is. This is the auto configuration, the IPv6 on the other end of the point-to-point link with the peer, the other end of the BGP session, I'm sorry, with the peer. So this is what we can see because it's directly connected with the peer. If that were not the case, we would see the IPv6 public address of the next hub. But since it's connected directly, this is what we can see. These are two lines. Well, you should be able to see it better. This is, what do we have here? I won't give you a prize because really you need, if you don't know this, let's just wrap up and leave. But what do we call this? This, right here. This is right here. This is like a rock concert. When I ask everyone here what this is, everyone should at the same time be screaming at the top of your lungs what this is. What is this? Well, the question is basic, but let's just give them a prize. A pen. Are you serious? Well, if you explain this well, if one of you explains this well, you can get a pen. Maybe it's not incentive enough for you to answer. This is so sad. Nobody wants to. Does that microphone work? I don't think that one works. You might need to turn it on. 65,000 is the first hub. It's an autonomous system. So it's my peer's autonomous system. So you need to take the next hub to reach the target or destination. Right, this continues right here. Autonomous system, next. And what is this called? IC path?
Lapicera. Muy bien.
It's the AS path. Okay, you want a pen. It's the AS path or the autonomous system path. Let me remind you that the presents we're giving you, the prizes, are Campus LACNIC prizes. Maybe Mariela Sandra can afterwards tell us more about Campus LACNIC. These are like the commercials you have embedded in a show. We're innovating. So the AS path after the destination network is the most important part of a BGP network. If you tell me the sequence of the autonomous systems whereby through which the information should travel to go from my AS to the destination S. What is the autonomous system that is generating? This is a question. What is the autonomous system that is generating this publication? So we couldn't hear the answer. He didn't use the microphone. 12654. The one that is right through to the end of the AS path, that is the autonomous system that generates this route. You read it from right to left. If I want to read it from the origin through to destination, I have to read it the other way around, from the right to from right to left. So I'm about to ask another question that deserves a prize. Let's see. If I would want to ensure the origin, this is a question. This is a question. Okay. Let me. One of these mugs or glasses that we have over here. So raise your hand. So if I would like to ensure the origin of a route, the question is, it has several sides to it. What is the protocol that I would have to use to ensure the origin of this route, to make sure what the origin is, and what I have to create, what would it look like with that protocol? Who would like to answer? We saw this morning. Please raise your hand. If you don't answer correctly, you won't get the mug, but please raise your hand. But please use a microphone, otherwise we cannot hear it. Yes, so that everyone can hear. The remote participants and the interpreters can otherwise not hear what you say if you don't use the microphone. Okay. To validate the origin, you have to use RPKI to be certain that the prefix is from who in fact says it is. So to use RPKI, what would I have to create in the RPKI protocol to indicate that prefix is in fact originated from a given AS? And what information should I have to include? What is it? A ROA, yes, a ROA. What would the ROA say? In other words, yes, create a ROA, and that ROA would have to say this network, this /48 prefix in IPv6 is authorized, or would authorize, the ROA would authorize that prefix to be originated in the autonomous system 12,654. So I have to create a ROA in the RPKI protocol stating that this /48 prefix is originated in the autonomous system 12,654. You won the mug. Congratulations. Well done. At least he was paying attention this morning. So now let us connect our router with the RPKI validator. So if you go to the lab guide, this part over here, oh, I have to change it. Let's see. Can you see it? All right, there it is. So what we will do now is to enable the RPKI protocol in the router. So go to the router first and enter the config mode, conf t, enter, and write RPKI enter. When you write RPKI in the router in the configuration mode, you enable the process, the RPKI protocol in the router. So there, you enable the RPKI protocol in the router. I'm going to do it here, conf t, I write RPKI, enter, and you will note that when you write RPKI enter, the prompt changes and writes the config mode of RPKI. So what I have to tell the RPKI process now is that how to find the validator. So you can specify this with the IP address, or also in some more recent versions. I didn't test this out. I didn't invest time in that, but I might do so later on. So if you have configured an internal DNS, you can use and assign a domain name to the RPKI server. You can enter the domain name of that server and use that as a mechanism. This will imply a DNS query, and you'll obtain an IP address, and you'll tell the RPKI protocol in the router which are the addresses of the validator, which are these two command lines over here. You have two validators, and also for the older versions of the FRR, they didn't allow you to specify these with IPv6. They could only be specified with IPv4. I think that was a bug. It was corrected, but I didn't correct it in the script of the lab. So we continue identifying the validator with the IPv4 address it has in the lab. But never mind, the lab is dual stack, so we can specify the IPv4 or IPv6 address, or in some cases, the server name. So once we enter the two commands, we'll tell the RPKI validator, the RPKI process, which are the two processes that we have. If you pay attention, one has preference 1, the other one has preference 2. This tells the router that it will always try to use the one with the lowest preference. If it cannot contact that RPKI validator, it will be using the other one. So the suggestion is, and this is a tip I'm going to give you. You can use it or not if you. One, recommendation and best practice, at least have two RPKI validators configured. Two. Why two? Well, you might wish to update the validator software or do some maintenance of the operating system. So you have to take down the RPKI validator. Just have one. All the routers lose connection with the RPKI validator. If you don't have a second validator, you won't be able to validate the RPKI. If you're using that for something on the router, you will stop using it. So at least try to have two validators. But some might say, well, I don't have resources for having two physical services for two validators. Well, you can download any software, virtualization software. It can be on where, for example, you can use this in a standalone machine. If you don't have the be alone, you can download this, which is GRUD. It has been tested for these environments. You install two virtual machines and two RPKI validators, and that's it. If the machine stops working, well, they won't work, but at least try to have two validators on two separate machines. But at least create two validators. So if you have a lot of routers, it is good if not always should be ending in 70 and preferring 2 and 71. You can put some routers with this preference over here, and for some of the other routers, the other half of the routers, in this other one. So the preferred one for the other half of the routers will be the other one. In that way, you're always using the two validators. Because what would occur if you have something as a backup, but you're not using it? And this is a universal law. If you have a backup, a 5-year backup, because you never tested it, if whenever you're going to use it, it will always fail. You didn't have backup. When did you try it for the last time? Well, I never did it because nothing happened in 5 years. But then the day you need it, it won't work. So if some are in with one validator and the other with the other one, whenever there's a problem, I will be able to identify it. So the recommendation, at least have two and always use the two. Some routers give priority to one and the others give priority to the other one. We're almost done. And the other configuration command is the one you have over here, which tells you how often you have to download the router from the RPKI validator from the validation table. Because the first question we have is, what time do I establish? This is established in seconds. This is 5 minutes here. I did this way because it's a lab. 5 minutes. There's no absolute value or absolute truth. This largely depends on many factors, the network size, but 5 minutes, personally, is definitely too short a time. In the case of a lab, we put 5 minutes because if any changes occur, we want to visualize things very rapidly. So every 5 minutes, we're downloading the validation table. But how often would you say that the validation table for RPKI changes? Whenever a ROA is created or disappears. So when a ROA expires or when one is created. So in addition to that, when you create in hosted mode a ROA in a RIR system, the RIR is not instantaneous. All the RIRs say how much time elapses between the moment you create it until it is mapped on the RPKI tables. This might take a few minutes, it might take a couple of hours, it can occur twice a day or 5 times a day, but it's not instantaneous. 5 minutes is a very short time. So this doesn't change so fast. So it would be far more reasonable to say a couple of hours, for example, 2 hours, 3 hours, or 4 or 5 times a day, 5 times. Otherwise, it would be too frequently, unless what you are doing is of critical importance and you have to be totally up to date with the RPKI table. If you want to have that really up to date, you can put 1 hour or 2 hours. However, in most cases, you can do this twice a day or 3 times a day, and that's enough. And remember, the shorter the time, the more frequently you'll be consulting the validators. So the greater the burden for the validators, and for the routers, this also consumes processing time. So the router has to do another task. If you put checking it once a minute, you will be killing the validator and the router. So let us do the configuration. We copy all this over here, completely like it is. Copy, and then we go to the router. We are in the RPKI mode, and we paste it over here. I pasted it again, that's why I get this error. I had already executed this. You have to execute all these 3 over here. And there we exit the config mode for RPKI. We write exit a couple of times. We go back to router super user mode. And to verify the RPKI configuration, we can use the command over here that you have in the practice guide. This command, show RPKI cache connection. So we write the command over here, show RPKI, show cache connection. We click enter, and if you pay attention, in fact, all the configuration appears with the 2 validators and with the preference, and it shows it's connected with the one which is preference 1. The router is already connected with the RPKI validator. So what changed? With that aim, you're going to visualize the BGP table of the router. You're going to put show BGP. Show BGP. Once again, we go back to the beginning of the table that we did today, and scroll up. And can you see any difference? This is a question that deserves a prize.
A pen, a notepad, well, something, let's say. A pen and a notepad. What's changed? If you can tell me what's changed in the path tables, what does... No, you already have one. You cannot have another one. If nobody else raises their hand, we'll give it to him. Okay, right there. Please come close to the mic.
¿Está apagado? ¿No?
Hola, hola.
Ahí.
Ah, sí. Ya la tabla tiene.
The table, there's a V at the beginning. Okay, so we have a new column that wasn't there before. Before the star, there was nothing, and now there's a letter. And what does it mean? That it's now using our PKI, the one that we configure, and that the path is valid. Well, that's what we can see on screen. And what are the three statuses? I know there's one more question, but what are the three validation statuses? We can also see the RPKI validation codes: valid, invalid, and not found. Okay, great. So this is a reference, as our colleague just said very well, RPKI validation codes, V for valid, I invalid, and N not found. And he very well stated, there's a new column before this star in the route, in the path table. All of the paths that are valid will be marked with a V, I for invalid, and the paths that do not have a row created, or those prefixes, will show an N for not found. Great. Well done. Now we have the validation status for the paths. Now what happens with those that are invalid? Is there anything that will be done with the invalid or not found routes, or nothing will be done? This is the question. It will do nothing. Okay, so let's continue with our practice to see what happens. Is it time for the break? For the coffee break? Well, someone just said that it's time for the coffee break. Okay, let's just do this very quickly, and before we go on to our coffee break, let's just run this command. Okay. So instead of using the whole path table from here to the end of the activity, let's just look at one particular prefix. Let's just pick one, and let's start doing stuff and analyze what's happening to the prefix. So it's 2803, column 9910, 8000, column /48. Show. No, let's scroll down. Let's just execute the command directly. This command right here. Let's just show BGP IPv6 and the prefix. We'll copy the command and we'll run it in the router. Right here. Show BGP IPv6 unicast 2803, so on and so forth. So it's one address for that prefix. So it will show this information. It's the information in the BGP table for that particular address. So what it's saying is that the address, IPv6 address ending in 1, belongs to that prefix 2803, so on and so forth, /34. It's part of that prefix, /34. So that prefix has this ASPA. In what autonomous system is it being originated? The prefix. This is a question. 64135. Going towards 65,000, and from 65,000 to my router, to the autonomous system. And right here, where it says RPKI validation state, it says valid. This valid is not the same as this valid over here. This is for the BGP path, the first one. Now we're focusing on the second valid, RPKI validation state. So if the status of that prefix is valid, means there's a ROA created saying that that prefix needs to have been originated in Autonomous System 64135. So what we'll do next? That was not the last activity before the coffee break. Sorry, let's just do something very quickly before, and Santiago will explain it. But after the coffee break, we'll analyze what will happen with that prefix. Okay. So I'll stop sharing my screen, Santiago, so you can show how to execute the client. Okay. So next, with our activity, we will execute an MTR. So please go back to your console, CLI. Is everyone there? I don't know if that was I don't know if that was clear. So you need to access the client. Just please keep the router open. Go back to the network diagram and click on CLI so you can access the client. And we'll execute the command that Santiago will explain next. So if we follow the guide, we'll execute the MTR command. It's a mixture of UDP and CMP. And we'll look for that IP address, 2803.9910.8001. So we didn't reach the final destination, but we can see that it is going towards the internet. It goes through several routers, and we'll keep this command on standby. So when we're back from the coffee break, we can do a path hijacking for you to see. So after the coffee break, we will do what we would call ill practice to analyze it, because as network operators this could happen. So we will use this as an example in view to see that, well, this really does happen many times. Is there anybody who was not able to reach this part? Open the client, execute it, run the MTR. It is a half an hour break. We'll be back at 4:30 and we will finish the activity. I think it's right outside. Our coffee break is right outside. If you don't want to leave your device here, you can just close it, take it with you, and once you are back, if you don't shut down your browser, it will not ask for password or anything. You'll just have to click again on the icon on the client in the network diagram. You're not going to lose your client configuration, or you can just leave your laptop here, no problem.